Hopefully the last video you watched on partial fractions made sense. If it didn't, then why haven't you emailed me? Okay, we're going to continue with partial fractions and take it up just a little bit. It's exactly the same process, but I didn't want to do all of it at once, okay? I wanted you to get really good with the linear factors before I kind of threw in quadratic factors. Remember that basically your first step after you double check about the power of the numerator compared to the power of that denominator is you have to completely factor that denominator. So all the ones you had for homework last time always went to linear factors. Now, sometimes when you reduce something factor-wise, you don't get just linear factors. Sometimes you get a couple of things. One is you get something called an irreducible quadratic. So that's a quadratic that you cannot factor any further. Let me give you an example. X squared minus 4, you can factor further. X squared minus 4 is the difference of perfect squares. So you can have an x minus 2 times an x plus 2. Even if it were x squared minus 3, you could factor that into x minus the square root of 3 times the quantity of x plus the square root of 3. So when you've got the difference of squares, you're good. But what happens is sometimes you have a squared plus a constant, okay? And then you can't reduce it any, you can't factor it any further. Like if you had x squared plus 4, you can't factor that any further. So that's what we mean by an irreducible quadratic factor, okay? It's a squared term plus that constant. And that's just a little bit, one little bitty difference, and then it's worked exactly the same. And then the other thing we're going to talk about in this video is when you have a repeated linear factor. Now, what do I mean by that? Instead of just having x minus 1 as one of your factors, what if your factor was x minus 1 in a parenthesis like cubed? In other words, x minus 1 times x minus 1 times another x minus 1. So a repeated linear factor. So those two things are done just slightly differently than the ones you had for homework last night. All right, so let's go do it. It's not hard. I just want to make sure that we're good with the others before we throw this one little twist kind of in. All right, let me go get that PowerPoint so I can pull it up and we can kind of start. Okay. All right, here we go. So partial fractions, so still doing the same thing, but this time we throw in some quadratic factors that we can't factor any further or a repeated linear factor. Okay, so let me talk about the quadratic ones first. So when you have an irreducible quadratic factor, okay, what you're going to do is before you put like capital letters like an A over a linear factor plus a B over a linear factor plus a C over a linear factor and so forth. The only difference is when you have an irreducible quadratic, you put like an A next to an X plus another letter. Like look down here. If one of the factors, when you factored your denominator, if one of them was x squared plus 1, well, see, I can't factor that any further. I could if it was x squared minus 1, but x squared plus 1 can't factor any further. So instead of putting an A over x squared plus 1, all right, you put a B, you put an A, but then you put plus like a B in front of an X. And it doesn't matter, you can put an AX plus a B, okay? But you need that single capital letter plus you need another capital letter in front of an X. So what you're really doing is kind of putting here, when you're putting like an A over an X, that was like an AX to the 0. So this one, the power of the numerator is still 1 less than the power of the denominator. So just make sure that if you have an irreducible quadratic, that you have a letter in front of X plus another letter. And you can do it either order, commutative property of addition. Okay, so let's go work one so you can see what I'm talking about. All right, here's the one I kind of picked. It's pretty straightforward. All right, let me go get a pointer so I can do it a little bit easier. When I take this denominator, I can factor this a little further. You know, x squared minus x will factor, I can pull an x out of that one. That gives me an x times an x minus 1, but I can't factor that x squared plus 4 any further. So right here is where I've got my irreducible quadratic. Now this is a linear factor, so just an A goes over that one, plus, it's always plus. That's a linear factor, so I put a B over the linear factor. But if you have a quadratic factor, you need a letter in front of that variable plus another letter. In other words, if these were Z's, you would have C in front of Z plus D. okay? So whatever your variable is, you need a constant in front of that plus another constant. So that C and D are constants. And this is what you do when you have a quadratic factor in that denominator. Now, from this point forward, it's worked exactly the same way you did before, okay? So what I'm going to do is I'm going to take this integrand and set it equal to my new integrand, okay? Then, just like before, because this fraction is equivalent to this fraction, okay, all I've got to worry about is this numerator equaling this numerator, okay? So what did you multiply x by to get this denominator down here? Well, you must have multiplied by an x minus 1 and x squared plus 4, so that old numerator a gets multiplied by an x minus 1 and x squared plus 4. And then it says plus, so I put plus. There's my old numerator b, so I have a b. Now, what is different about this denominator than this new one? Do you see there's an extra x and an extra x squared plus 4? So that's why that old numerator b gets multiplied by those same two new things, x and x squared plus 4. And then plus, what's different about this denominator and your new one? Well, now you have an x and an x minus 1. So your old numerator, cx plus d, gets multiplied by that same thing, x times x minus 1. So this is exactly the same process that you were doing before. Not anything different about it, okay? So what you're going to do is set the two numerators equal to each other and do what we did before, okay? We are simply going to multiply that right side out. We're going to group like terms. And then we are going to, let's see if we can pull this up a little bit, see it a little bit better, okay? Then after we group those like terms, we multiply it all out like we did before. See, x minus 1 times x squared plus 4. X times x squared is x cubed, plus x times 4 is 4x, minus 1 times x squared is minus an x squared, and minus 1 times 4 is 4. And then plus the b, I multiplied x times x squared minus 4 and got that. Multiplied x times x minus 1 and got that. Then I distributed a times all of those and b times all of those. And then I did what you think of as FOIL. I don't like that term, but there you go. I multiplied that out. I got all of these factors, and then I grouped the ones that were alike together. I had a cube there and a cube there and a cube there, so I stuck all the cubes together. Then I go hunting for my x squareds. Then I go looking for just my x's, and then I go looking for my constants. So that process is exactly the same as you had last time. Now remember what you do after you group. You factor out the things that are alike, okay? So that's just kind of the end of the last slide. So my things are grouped. All those have an x cubed, so I factor the x cubed out. All of the next ones have an x squared, so I factor the x squared out. All of these have an x, so I factor out the x, and then those don't have a variable. Those are my constants. I only had one of them, okay? So I find it helpful to underline things that are the same or circle them or something. Now, once you get these things factored out, remember what you do. You make a system of equations by setting the coefficients on the left equal to the coefficients on the right, and the constant on the left equal to the constant on the right, okay? So here's my constant for x cubed over here, and then that 2 is my constant for x cubed on the left side. So I set those equal to each other to get my first equation. So this first equation is just the coefficients of your cubed on the right equals the coefficient of your cubed on the left. And then they do the same thing. I take the coefficient of x squared, negative x minus c plus d, negative x minus c plus d, and I just set it equal to, now notice what I did. This is just me. I do better if I actually see things. There's not an x squared term here, so I stuck in a 0x squared. What's 0 times x squared? Well, it's 0. But I'm afraid I would forget, I wouldn't know what the coefficient of the x squared was over here if I didn't put that factor in. Okay, I mean that term in, not a factor, but a term. So I don't have any x squareds over here, so the 0 coefficient on the left side equals the 0 coefficient on the right side. And similarly, there's my coefficient on the right side for my x's, and there's my coefficient, that negative x. Do make sure you take that sign with it, that -4, and put it here. And then I've got my constants. My constant on the left is a -8. My constant on the right is a -4a. Well, see, this fourth equation is already solvable. When I divide both sides by a -4, I just get a is 2. So now a is 2. So what can I do now? Well, do you see that I can now take A is 2 and plug into any equation that has an A in it? So all three equations have an A in it. So what I'm going to do is I'm going to put that 2 in for A here and here and here, and then I can make those equations look a little different. So if I put a 2 in there, I'm going to have B plus C left. And then when I take that 2 and move it over, it's going to be minus. And so that's why I got B plus C is 0. I put A equals 2 right there and subtracted 2 from both sides. Similarly, to the same thing here. I put this negative C plus D. See, negative C plus D stays the same. But I put a 2 in there, but there's a negative in front of it. So if I take that negative 2 and bring it over, it becomes a positive 2. And then so forth. I put 2 here. And then 4 times 2 is 8. And then when I bring that 8 over, it's negative. So a negative 4 plus a negative 8 is that negative 12. So now these become my new 3 systems. Okay, my new 3 sentences in my system. So again, I've got to solve these. So I've got a couple of choices. They don't all 3 have the same variable. So I've got to find some way of getting 2 equations and getting one of the variables to go out. Well, see, these, I basically, with those 2, look what I can do. Okay. I went over to the side and said, look, if B plus C is 0, that means that C would be a negative B. Okay, so this is just algebra 2, algebra 1, all right? If I know that C is a negative B, I took this next equation and in place of C, I put a negative B. But there's a negative in front of that. So I put a negative B in for my C. Okay. So that's my negative B that's in place of that C right there. But I still have a negative in front of that. Well, see, an opposite of a negative negative is a positive. So that's why that turned into a positive B. Then I still got plus D is 2. Now, why did I do that? Because, see, this equation has B and D's. So I needed another equation that had B and D's so I can make something go out. So I put my new equation 2 with my equation 3. The D's were opposite, so when I added those equations, the D's went out, and I've got 5B is a negative 10, so when I divided both sides by 2, I got B to be a negative 2. Now, what can I do now that I know that B is a negative 2? Well, I can substitute that into the equations. And so that's what I did. Went back up here and put a negative 2 in for my B on this first equation. So if negative 2 plus C is 0, then C must be a positive 2. Well, see, now I know what A is, I know what B is, I know what C is. Now I can go find what D is by substituting either in this one or in that one. Okay. All right, so I did, and I got 4. Okay, so let's see if you can see it back here for a second. I don't think I took time to do it. All right, but if I know that a negative C plus D is 2, okay, remember what a negative C is. C is 2. So a negative 2. So negative 2 plus D is positive 2. So when I bring that negative 2 over, that's where I got my D to be 4. So now I know that A is 2, B is negative 2, and C is positive 2, and D is 4. So now I finally go back to my calculus, and I substitute those in. A was 2, B was that negative 2, C, the number in front of X, is another 2, and then plus my D was a 4. Now I'm ready to do calculus. Well, now remember, when I see a fraction, the first thing I think of is natural log. Well, let's see if I can do it. Do you see this one's easy to get natural log? Just pull the 2 out, and you'll get natural log down here. Again, the derivative of that denominator is 1, and the easiest way to get a 1 right there is to pull the negative 2 out. But this one's problematic. The derivative of x squared plus 4 is just 2x, and I got that extra plus 4. And I think I wish I didn't have it. And that's why I thought, well, I could break it up into 2x over this, plus, and then put the 4 over that. Because the derivative of this denominator is that. So these first 3 are just natural logs. But now what about this next one? Well, I've got to go back and start over. Okay, so it's not power rule, because I don't really have anything to a power. It's not natural log. Okay, So what is it? Well, it's arctan, because I've got something squared plus something squared, okay? And so I went ahead and showed you that, you square x to get x squared, and you square 2 to get this. So that means that your u is an x and your a is a 2. Remember, you need dx on the top, the differential, but the derivative of x is 1. And then to get this part right here, all right, all I did was I went back to the book and found my arctan formula, which is 1 over a. Remember, we said that a is the number that you're squaring. Arctan of u, and my u was x, over a was 2 plus c. Okay, so the only difference in this and the ones you had for homework previously is the fact that you may have that irreducible quadratic. So instead of just putting just a c over x squared plus 4, you have to put c in front of x plus d over that. Okay. So let's go look now at repeated linear factors. Okay, let me erase these marks so that doesn't distract you. Now, what do I mean by basically a repeated linear factor? Like I said, look right here. What if one of your factors on the denominator was x plus 4 in a parenthesis cubed? That means x plus 4 times itself 3 times. Okay, when you have a repeated linear factor, you go back and use single capital letters, but it's got to be over this factor and every power to that one. Now, what do I mean by that? That's a cubed, so I've got to have something over x plus 4 to the first, and something over x plus 4 to the second, and something over x plus 4 to the third. So that's what I mean by when your denominator has a linear factor to a power greater than 1, you have to put a capital letter over that linear factor and every integer power of that factor less than or equal to that factor. So if this had been to the 5th power, I'd have had to have that thing to the first, the second, the third, the fourth, and the 5th. Okay? So I do want to make sure I'm clear about one other thing, and that's this. This used to get me kind of confused when I was a student. In my mind, that was a quadratic factor. So I thought it was like the irreducible quadratic we had a minute ago, but it's not. X squared means x times x, which is a linear factor times another linear factor. So if I had an x squared, again, I would need a capital letter over x to the first and a capital letter over x to the second. If that were x to the 4th, I'd need an x squared, an x cubed, and x to the 4th, and I would have single capital letters over them. So an irreducible quadratic, like the previous example, means you have a quadratic plus a number, not just a quadratic. So all that happens here is you've got multiple linear factors. So let's go work one like that, okay, so that you can see what I mean. Okay. All right, here's one right here. It's got kind of a variety. Okay, so let's kind of pull it down. If I fully factor that denominator, I pull an x out first, then that leaves me x squared plus 2x plus 1. So that factors into x plus 1 times another x plus 1, which is x plus 1 squared. Now, the x is just a linear factor. So that's why there's a single capital letter over the x. Now, this is a linear factor to a power, okay? So it's not a quadratic factor, it's a linear factor. So I need this to the first and then this to the second. And again, you put single capital letters over linear factors. Now, if this power, heaven forbid, had been a 5, I'd have to have a first power, a second power, a third power, a fourth power, and a 5th power, okay? So if that doesn't make any sense to me, you need to email me and we'll get together on a one-on-one Zoom and talk about it. From this point forward, it's just like the ones you had for homework, okay? So I set this integrand equal to this integrand, okay? Remember, I get that common denominator, so you can see that the fraction on the left is the same as the fraction on the right. Since those denominators match, that forces the numerators to match. So all I've really got to worry about is setting the numerator on the left equal to the numerator on the right. So that's kind of where I work from now. Okay, let's pull it up a little bit, hopefully, so that we can see it a little bit. And then I multiply it out. I multiplied x plus 1 quantity squared and got that. I distributed my a and got ax squared plus 2ax plus a. X times X plus 1 is X squared plus X. Then I distributed the B and got BX squared plus BX. And then C times X is just CX. Then we do the same thing we've done before. We group like terms. I just kind of was running out of room, so I kind of did some things. So do we understand that I grouped the AX squared and the BX squared together? Then I factored out the X squared, and that left me A plus B. Then I had the 2AX plus the BX plus the CX. So those three terms, when I factored the X out, that left me the 2A plus the B plus the C. And then A was the only one I had without a variable. So remember what I'm going to do on this next slide is I'm going to set A plus B equal to my 5. And then 2A plus B plus C is going to be this 20 over here, this coefficient. And then A is 6. So I've already got A solved. I already know that A is 6. And then there's the first two equations I kind of talked you through. So the coefficient on the left of your X squared equals the coefficient of the right on the X squared. So that's what the red one is. And then the coefficient of X on the left equals the coefficient of X on the right. That's equation 2. And then when I set the constants equal, that was already a solution. So I can put A equal to 6 in both of these. Well, now look what happens when I put A equals 6 into the first one. When I put A is 6, I don't have to do much work. I just subtract 6 from both sides and I've got B. Well, now I know what A is. A is 6, so I can put in 6 here. I know B is a -1, so I can put -1 in there. And then C comes out to be 9. So with very little effort, I had my A, my B, and my C. So once I know what those capital letters equal, now I'm ready to go back and do the calculus part, which is simple. So I go back to my original integrand. Now I know that A is 6 and B is a -1 and C is 9, and I do the integrations. When I pull that 6 out, do you see that I've got natural log right here? Well, the derivative of that denominator is 1, so the easiest way to get a 1 is to pull the -1 out. Now this one, when I pull the 9 out, this one's not natural log, because I would need the derivative of that denominator would be a 2 times an X plus 1 times a 1. But when I pull that 9 out and I just have 1 over X plus 1 squared, it dawns on me maybe it's power rule. But if it's power rule, that power needs to be in the top. So when I move it to the top, I see very quickly that the derivative of that inside is just a 1. And I already have that, so it's just power rule. Remember what power rule says. Your power goes up by 1, so my power would go up to a -1. I got divided by that same power. And then these were just power rules. Plus and negatives, just a minus, and then there's that 6. So I've got 6, and then the natural log of that denominator, plus a negative is minus, and then I've got something on the bottom, it's derivative on the top, so that's the natural log of that denominator. Then remember we talked about the power rule. So there's my answer. Now I do want to make sure you're clear about this. What I have boxed for me is fine. So on your test, on your third test, if you want to leave it this way, that's great. But when you turn to the back of the book, sometimes if you have logs, they'll use those log formulas. Remember when you have the difference? So first of all, powers can be moved from powers to coefficients. Well, that means they can be moved back, okay? So right here, I need to fix something, okay? Because I wanted to make sure you saw that because I have a mistake. This coefficient isn't a square, that coefficient should be a 6, okay? Because that power could be moved up there. Then I have the minus. Remember when you have the natural log of A over B, it's the natural log of A minus the natural log of B? Well, this is just this in reverse. See, that would be the natural log of the top minus the natural log of the bottom, which is what this is. So sometimes when you turn to the back, if it's log and your answers don't match the back, double check those log rules and see if they just got the same answer in a different form. So really, the only new thing that in this video shows is when you have irreducible quadratic functions, all you need to do is make sure that you have more than one. In other words, you have to have capital letters over that one, then all the ones up to that one. And then make sure that you realize when you have an irreducible quadratic, which is a quadratic variable plus, and then you got that constant, you have to have like an A in front of an X plus a B, or an M in front of an X plus an N. So a letter in front of your variable plus another letter. Then it's worked exactly the same. You're going to end up making a system of equations and solving that system and then going back and doing the calculus. Okay? So I don't think you'll have any trouble. try that homework, and just like usual, if you do have trouble, though, email me and we'll figure out the best way to get you some help. Now, you've only got one other new integration, and that's coming up next time. So kind of preview of coming attractions. All right? If you need me, you know how to contact me. Don't sit there lost. Have a good day.